the
Hey, everybody. Sorry, guys. I just want to let you
it's a
guys know
sort of
I hit live, so we might have a few summertime viewers showing up in a couple minutes. But um, let's take it from the top there, because while I was doing it, I was curious just on what Jay asked around the bill of materials. I have the bill of materials from the last one, and we're based on what we've decided over the last couple of weeks. We're uh, sort of amending that, but it's not yet on the GitHub. But sorry, David, I interrupted you.
okay. I thought the bill of materials was on the GitHub.
It is. It is
That's
on the GitHub, but just not the
okay.
updated one with the new stuff.
Oh, okay. Also, I haven't drawn a complete block diagram or schematic or anything because there are just too many wires, and I haven't had a lot of time. But I have put up a document that explains it's almost done. How most explains most of how it works, and there's a very high level diagram, as well as some descriptions of some of the components. And I think that's
And
also
that,
on the same GitHub under hardware description, I think.
Yeah. Okay, cool. Well, David, we had a really good call last week, which was really made a good call because of the very good call we had. Oh, great. Here's Charles. Because of the very good call we had the week before, or was it 2 weeks before, with Kirsch at Clarity. And I've kept my conversation going with him on WhatsApp, but we kind of digested some of the great stuff that he shared with us and really have committed more to just kind of going for this honeycomb method and really looking at retaining the maximum amount of stuff that we currently have in our current design and swapping out a couple of things to make it work with honeycomb. So curious, since we haven't talked since the first call, though, just wanted to see if there was any bolts of lightning that kind of hit your head that were particularly clarifying from that call. Or did we talk once? I am completely, but just curious what your latest thinking is, because we can explore a couple of things in more detail once we hear from you. Oh, am I frozen? Oh, David, sorry, that was for you.
Oh, I'm sorry. What was the
Yeah, I was
question?
curious, and I think that was a great call we had with Kirsch from Clarity, and it really has kind of committed us to going with the wash-coated monolith. And I'll share too. He shared a specific sorbent that I looked up on Sigma that he thought would be good and very workable for this. But I just didn't know if there was any kind of epiphanies you had or further thinking you had from some of the stuff that he shared.
No, nothing more. It was an interesting meeting, though.
Yeah. So we had last week. I did share a couple of slides. I don't know, Seth. Do you want to summarize it, or do you want me to summarize it? Just kind of the basic idea is we want to hack out the existing sorbent panel we have, just the dimensions of it, gut it so it's no longer 80-20 dumping, the sorbent pellets into the box with the thermocouples, but instead take those dimensions and insert the wash-coated monoliths, probably 4 of them, the ones that I found that we could just make a full cube out of, and then put heating elements on the front and on the back of it externally rather than on the inside. And what I did in the last week is I just looked for some perfect square honeycomb monoliths that are ceramic that we could use for this. And as I said, I got a specific recommendation on a sorbent that Kirsch thinks will meet our purposes. Anything to add to that set that we discussed last week? Oh, we got a couple more people here. Sorry.
No, I think that's pretty accurate. The idea of the heating elements was really to heat the air rather than to try to heat the honeycomb directly with the monolith, and that was just to allow for more even heating.
Yeah. Did you have any concerns about that approach or any things that came up, David, that you were kind of, again, it would be awesome if we could just take out just the panel and use everything else, and obviously put new heaters in there, but we have room for that within the bulb of the broader chamber that the panel fits into, but didn't know if you had any concerns or questions that still need to be answered before we design for that?
Well, my understanding is you're blowing hot air in to heat it up, and so that means you're not going to be doing the desorption in a vacuum, unless you count on the material heating up and staying hot, and then you pump out the air to make the vacuum, and if it stays hot, that should work.
Yeah, and he said to us, oh, go ahead. Sorry, that maybe he he obviously mentioned that they don't use a vacuum because of the low void fraction. That there's enough stuff taking up space within it. So that sounds great if we're able to achieve a similar type of thing. This was the image that we showed last week, David, just to kind of put a finer point. We're looking at something kind of like this, and if we could take like 4 of those and more or less fit them within, take away all the 80-20 and just fit it within that frame, and then just go ahead and insert it, right into where we used to put the other thing, and then hopefully we're good to go. And then again, the idea is that we put probably a heater on the front and the back. I've looked at a couple of them that are off the shelf, these sort of open coil heaters that we'll just want to make a pick for that. I might ask Chuck what his sort of thoughts are. Some of these are actually in HVAC catalogs that I found. Yeah, so doing that without a vacuum is the idea. That sounds right to you. Hey, Ling, how you doing? Anything to add to that?
No.
Okay, great.
Yeah, I think
You and Ling are meeting up.
I agree with
So we can talk about it tomorrow over coffee. But go ahead, Seth.
I was just going to say you're right about the vacuum, David. That with the current setup, there's going to be too big a void fraction, and it'll affect our purity. But we figured let's take the one step or smallest step approach and deal with more impure CO2 for now, and then we'll decide whether we want to worry about pumping down to a vacuum or all the way to a chamber so that there's a higher void fraction, lower void fraction.
Yeah. Do you have the exact dimensions of the outer frame of the sorbent panel handy at all? I wasn't able to crack open the GitHub before jumping on here, but the reason why that's relevant is that I found these perfectly square ceramic monoliths that I'm hoping we can just do a quad of those that can fit directly into it. But yeah, I didn't know if you had that handy or knew off the top of your head.
The current box is 24 inches square,
All
and
right.
then the part in the middle that holds the sorbent is 8 inches square.
Okay.
So it takes up 1/9 of the potential area.
So we're gonna get rid of that totally. The little box in the middle. These were the ones that I found on eBay that are a little pricier than some of the other ones, but they're certainly not deal breakers here. Let me just share it with you.
David, is that 24 inches the interior or exterior dimensions?
I don't know. It's pretty thin metal, so
Okay.
within say 16th of an inch error, it's about the same.
Oh, okay.
Let me do a conversion here with what you see on the screen there, unless somebody knows it off the top of their head. Millimeters to inches. So one of these. Oh, go ahead, Link.
It's like 4 inches by 4 inches by 2 inches. Wait. Yeah. An inch is about 20 millimeters.
24.5 millimeters per inch.
Yeah, it is about 4. Yeah. We could probably get bigger ones. Or we can get a bunch of little ones. I don't know. It starts to add up a little bit in price, but
Little ones are easier to do.
I think, right?
Do you know how much sorbent those would hold then?
I don't know. I mean, he gave us I asked him I asked Kirsch. He thought that we would need about 100 grams of PEI, PEI liter of brick volume coated on the surface. I don't know. Math is not my thing, but
These look really dense, so they might pick up more PEI or whatever sorbent that we're using, and so higher surface to volume ratio is good for two reasons. One is that we'll expose more sorbent to the air, and the other one is that we'll like within the same solution that we're dipping into, we'll pick up more sorbent, so it's a bit more efficient in terms of sorbent use. But it looks like maybe it's expensive, so that would be the trade-off. If we can use this for a long time or reuse it, then the cost may be negligible over time.
yeah, that's what he thought, Kirsch, is that it lasts, a very long time. It's not the kind of thing that we have to swap out on a regular basis. So, I'll look and see if there's other cheap ones. I've asked him what his thoughts are on the particular thing that I just showed you, and I'm waiting to hear back from him. But there are other options. It's not like a thing that we're swapping in and out, regularly. It's, it would work for a long time. All right. This is the sorbent that that he also recommended. Let me just share my screen. This one here. Oops. It's a polyethylamine branched 800. Emily, make sense of what that means. But this is one would be a good one that we could just order directly from Sigma. And he can give us, I think, a sense on the sizing of it based on how many of those monoliths we buy. He thought that this would be good. So I'm inclined to follow his lead on that if anybody has any objections. I'll drop the link. Putting the link in the comments. Who here among us, Charles? You know a thing or two about the chemistry side of this, right? Obviously, it'd be great to share with your buddy Will, but if you could, actually, that'd be great.
I'm not terribly well versed, but I'll share this with Will.
Okay, cool. All right. I will turn that off. So anyway, I was hoping to have more confirmation just on the monolith side, but if we hear from Kirsch that he thinks that or if I could find a slightly cheaper monolith that has those dimensions work, and then if we go with this sorbent, he could help us determine how many bottles we have to order. But my inclination is to kind of go with that if he said yes to both, unless anybody has any objections. All right, not here. And on the last call that we had, again, we want to just gut out what was you said something, Ling, about the frame that we could probably just literally again go with this, keeping the 80/20 it's just the basic frame, but taking everything else out. Was that what we were leaning towards? Oops, let me get rid of that. What is that? Oh, I gotta stop sharing. This here.
For replacing with the monolith, I think
Well, just trying to think, what do we want to fit in? What do we want to use as the frame to fit the monolith in? That's a square. Do we go with something totally from scratch? That's just a square that has none of this other stuff in it, or if we're taking the plate off, just don't know if anybody has any thoughts on how we designed that very basic thing.
Yeah. Actually, But beyond the fact that I think we should make a stand for it, like make a base for the monolith. I have not thought about how to hold multiple monoliths together if that's what we're doing. But it's possible to find.
Yeah, I guess if we also find once we have the dimensions of the specific monolith cubes kind of nailed down, I wonder if there's something we could put in here like a quadrant, of just some basic material, that a piece of metal or something that would give this almost like a tic-tac-toe board type of look, and we just insert the different monoliths in it for that shape. I don't know.
For the purpose of like commercializing this, that would be nice. But here, if it's R&D, like the mono have holes, so we can just tie them side by side together with like some. It'll be fast, cheap, and like very easy to do.
Hey, are we committed to sticking with the 24-inch square box and frame, or are there other smaller ones under consideration?
I think we're not committed because first of all, we don't want to fill the 24 by 24 because some of the space will be wasted in the corners. But also, like for price reasons or whatever, we're more flexible. Oh, and also like we maybe don't want like one big piece. It would be harder to dip. So like having multiple smaller pieces might be easier to handle. Yeah. As for like filling out the whole footprint, like or cross section area, I feel like we should fill it pretty well, but it doesn't need to be perfect.
Yeah, and Seth brought this up last week that we can deal with the corners having a little bit of loss if it's not directly there, if it makes for a better slugger fit. I think if we can just have square monoliths fitting into a square frame, that we don't have to make really any other changes. But David, did you have an idea there when you asked if we're committed to that? Was there another sort of approach that came on?
I haven't even looked at it, but I would imagine that there are smaller ductwork things we could find. The same kind of thing, but on a smaller scale, or even something that's just a straight duct that doesn't open up like that into funnels, or a round pipe, or there are a lot of different possibilities I can think of.
Yeah, we had talked about PCP pipe and stuff like that.
But since all those honeycomb things seem to be square, then it may as well be a square thing. So
there's circular ones too. Yeah, there's actually, if you look at this one here, there's all variety of it. That I showed some pictures before. So if you look at this here, you can see a circular one there. I guess the thing I was just sort of thinking was that because, again, going into the Clarity lab and seeing it the exact same shape as ours, that they had a good reason, I guess, to kind of give it that sort of bulbous shape. And that if we want to really repurpose the one, I'm going to be in Philadelphia at UPenn, David, for that event that I got invited to speak at it on September 18th.
Oh, cool.
So I'll be able to be in town and actually go and see the thing live, and hopefully that is an occasion where we can, particularly if we have some of this worked out. But I like the idea of being able to totally use the one that we have in Pennsylvania, and being able to just insert a new absorbent panel in there that works with a honeycomb. That was sort of my thinking, and I think we kind of all liked that idea last week.
You just need some hands that'll do it.
Yeah, which again, I think that I'm going to set up some time with Peter and Jen and this guy that he's been referring to while I'm there, to really get that catalyzed. So I'll keep you posted. It'd be awesome if you're in town, David. If you wanted to be able to come and sit down for that, it would be awesome.
Yeah, what sort of event is it? Is it open to the public or?
Well, it's actually it's the Office of Fossil Energy and Carbon Management that is actually putting it on, and a lot of it will have a focus on the overlap between industrial decarbonization and carbon removal. So the panel I'm on is about the intersection of concrete and CDR. So it's a really, it's the Fed is basically partnering with UPenn to put the event on. So it's going to have it'll be pretty great. I'm sure I could, get you into it if you wanted. But for me, it'll be awesome because I'm obviously very invested in that subject, but to be able to just have my feet on the ground and hopefully get things sort of well situated for, Epiphyte stuff to continue. So this is the event I remember Peter mentioned to us when last time we spoke to him, which he thought would be a good opportunity to get some enthusiasm for Epiphyte. So anyway, that was our thinking. Just trying to repurpose as much as we possibly have here, David. If ultimately we want to go down to a cylindrical one, that'd be great. But if we can make this work, I think that'd be awesome.
Mm-hmm. But at some point, somebody's going to want to build a new one, maybe in Texas, and then you have an opportunity to not be locked into the existing box.
Yeah. But I'm telling you, what is we definitely, as Charles, we have funding to build the one in UT. So the plan is we talked about it the other day on a separate call, that the plan is to build one of these in UT and to get the group together, at the end of August to start thinking that through and to build it this semester. So that is absolutely the plan. But I'm just trying to think at this point, if we think that there's a downside to keeping the architecture that we have, particularly if we're able to use this other monolith and heating system within it, unless there's some real compelling reason to go with a PCP, approach, I wouldn't mind seeing if we can, make a go at these other same parts just because we've used them before. Mm-hmm. But speak now, David. I defer heavily to your thinking on this, and Charles as well. It's him and his team that'll be building it, but let me know.
Well, I don't know much about airflow and the considerations there are. I don't even have an intuitive feel for it. So somebody that knows more about that kind of thing, like HVAC or mechanical engineering or something, might have an idea for why you want it to spread out or why you don't want it to spread out. And there'd be trade-offs, I guess, with how fast the air would be flowing through, and are there speed limitations to how, to the effect of how much CO2 the things can pick up?
Yeah. Well, I guess, Charles, we'll talk about that when we get together at the end of August, and keep all options up on the table. But it's good to know that we could probably make a good go at what we currently have. I think one of the things that's interesting, David, with the PCP one is we could possibly, I guess, in sort of series next to each other, you could get a monolith that's circular that fits right into it, and you do a few of them. And because it has these holes in it, there's probably not much of a resistance downside if all of those monoliths line up nicely. I don't think having multiple monoliths that are sort of almost in the barrel of a gun kind of lined up one after the other, I don't think there's going to be much of a added resistance probably from that. So we'll definitely consider it, but again, it's good to know that we can, probably build on the design that we currently have. And I'll ask Kirsch as well if, what he sort of thinks about one or the other. Obviously they're fine with the way that we do it because their system looks almost exactly like it. So, we have two. Let me see here. Elon asked a question here. Let me just pop it up here. The Epiphyte device still has a rich CO2 stream as an exhaust. What did he say again, guys? I think he said it was like 90% purity, right? For the CO2. This is Kirsch using the monolith. I love that idea, Ilan. We've talked about that a lot. This idea of either having a chamber below that has brucite in it or some other ultramafic that is in solution that you pump CO2 into, or having something that has algae in it. The benefit of having a mineralization is that then it's with algae you still have something that's not really a durable form of storage. So you'd have to really think of a creative way to use the algae, unless you're doing something like a coccolithophore, which produces calcium carbonate. But definitely share some more ideas there if you have cool algae ideas. All right, I think the thing that we want to do next is just to sort of get a heating element that's not going to be dangerous, that can fit within the void that we have within the bulbous chamber. That might be one reason too, David. I don't know. We could probably find a heater that we could fit into a circular thing, but having a bulbous maybe gives us a little bit more options for having a heater that's sort of square shaped and a little bit larger, which to be more common in the things that I'm seeing, at least. Just dry algae. I see what you're saying. We'll share some more ideas there, Ilan. That's certainly a bit next step for us, but we all are very much on board with the idea of being able to make a solid carbonate or something solid out of the carbon, right within the unit at some point in the not too distant future. So if there are interesting algae drying ideas, one of our guys, Ben, at UT, for his little document, he actually did use algae. So it's definitely something we've been thinking about, but keep chatting with us if you have cool ideas for it. All right. So anybody have any other things to discuss? Again, I think for me specifically is to just try to find, if somebody could help out with an alternative idea of thinking about what the frame would look like, that we can slide in there using our existing thing, that would be great. And then I'll try to find a specific product that we can buy from monoliths. And then hopefully by next week, maybe we're a bit more confirmed on what we want to pick. But let me know if anybody has anything to bring up. Go ahead, Jay.
You're on mute.
You're good.
Sorry, thank you. I understand that the air is being pulled through the sorbent. Is that right?
Yep. Same as before.
And the fan runs 100% of the time?
Do you mean in the current design?
Yes.
It only runs during the adsorption phase, and then it stops when we're doing the desorption.
And what's the duty cycle, you think? Between fan and heating?
Maybe 50%.
Okay.
And we tried different variations on it and didn't really learn enough to come up with anything firm.
Okay. And do you think that the area of the holes in the monoliths seem pretty small? Do you think that's going to interfere with the airflow?
I have no idea. That's the thing that Chuck knows a lot more about than I do.
Will what interfere with the airflow?
The monoliths?
I think it will.
That's why you're picking it. But go ahead, Lane.
I think it will be noticeable, but like interfere, if you mean like completely block, no. But it will create some resistance because like this is fluids 101. If your cross section area is smaller, then it'll be like it's pretty long, right? Like the aspect ratio of the length of those funnels versus the cross section area. So you'll see noticeable resistance, but it won't be like the work really hard to get the air to go through. The air will go through.
The airflow for the fan is about 1,200 CFM. Do you have an estimate of what it'll be when those things are in the way? Do you think it'll be half that?
No, I'm a microfluidics person, not a macro person. But um, but my gut feeling is that it won't be too big of a problem if you have leaks. Whereas if you have like sorbent with that's tightly packed, then if you have leaks, the air will certainly just go through the leaks. So that will not be the case.
So did we measure the airflow with the pellet sorbent? How did that compare with the fan?
I it was hard to measure because I had this little handheld airflow meter, and it varied depending on where I held it in the duct. It wasn't mounted anywhere. It's faster in the middle and slower in the edges. Um, and the fan has 8 speeds, and we usually didn't run it any higher than the third speed out of 8, just because I was afraid of it actually blowing the sorbent out because it was a very powerful fan. It was probably overkill for this application.
Well, more air, less time, you'd probably be more efficient. To get the volume of air, get it captured as quickly as possible. You're using less energy. Might be a good thing if you
Yeah.
can hold the sorbent from getting sucked out.
Mm-hmm.
Yeah. Because that was a problem with the cyan, is you have to run it too long
Yeah.
To get completely the charge completely captured. So having a good fast fan seems like a good thing. And then if you're going to have that fan, if you have restrictions, maybe you can overcome those restrictions by running that fan higher to totally capture the charge in the monolith. That seems like the least amount of power you would use for that capture. And that goes really to your capture of, power efficiency. Because, anytime you run that motor on grid power, you're generating CO2, and you want to capture more CO2 than you generate.
Oh yeah. Yeah. That's a big thing that I don't even know how you model that.
Oh.
Well, we can estimate it, right?
Yeah, and again, we'll continuously try to improve on that as we go. As we've said before, I think if we can not be too particular on the full LCA of this at the moment, and just get something that works better on the fundamentals, and then work backwards on getting a better LCA. I mean, there's other things we could do with this that me as a solar guy, I've thought for a really long time. Being able to, it's an electrical system, build something that has a solar component to it. I think we could think of ways to improve that. But let's do this. One thing I want to do, Christina, sorry to call you out on this because you might be away from cam right now, but wanted to just check, David, are we good on the additional documents or write up that Christina has been asking for the GitHub?
It's like 80% done.
Okay, so we'll keep chatting about that and see what remains to be done on that. Christina, I didn't know if you are there, if you had any other things that you wanted to sort of flag related to the documentation side. I know you've been waiting on that for a bit, but if there's other stuff that you're doing, let me know. And again, if I'm catching you while you're running to grab coffee, that's okay.
I'm just in a loud place. Check the chat.
Oh, okay, gotcha. Oh, got it. Okay, cool. Very close, she says. Okay, excellent. And then if we're done with business for that, I did want to. Today's kind of a hallmark day for OpenAir because we launched a tool that I think is useful for DAC lovers and people who are into CDR more general. That I wanted to just give a quick advert for, and that is CDR AI, which we've referred to on this call a couple times before, but this is an LLM, a large language model that several members of OpenAir have been developing for a a really long time, several months from concept to beta launch today. And I'll just give you a little screen share of that. And this is a LLM, which I'll drop the link for a second in the channel, as well as a little descriptive article that we put on LinkedIn. But the back end of this, we made one. What's useful for this is that we, as OpenAir, control the data that the LLM draws on to generate responses. And we created a set of criteria around that to ensure quality. So the vast majority of the 630 something documents that we currently have in there are peer-reviewed articles that have been selected from top-rated academic journals. We have as when I share the link, we have a particular metric for that. And we use just search terms. We didn't go out and try to cherry pick, what are things that say nice things about CDR, but rather put in things like direct air capture. And, we had about 50 different search terms and went out and found those articles and uploaded them, as well as we have some data that was produced by national labs and other government documents, and some things that were produced by high quality university presses as well. But at this stage, it gives pretty good answers, certainly for people that are just trying to wrap their head around some of the important concepts. But we have a lot of stuff in there that actually pertains to DAC innovation, DAC students, novel DAC approaches. So again, we can demo that right now. Does anybody have, at the risk of it falling flat, does anybody have a kind of a geeky DAC question that I can use just to quickly demonstrate about sorbents, or anything that you want me to plug in, and I could just to show what it looks like?
How do you optimize the airflow in an Epiphyte-like system?
Well, it doesn't have anything about Epiphyte specifically, but I'll say, why don't I say this here? Flow let's just start very simple. Air capture, so it is most efficient. All right, crossing my fingers. It usually takes about 5 seconds to generate an answer. While that's happening, I'm just gonna drop the link here in the comments for anybody who wants to try it. Just put it in there. Okay, let's go back to what the answer is. So, I mean, in concept, it gives obviously very specific thoughts on that. But the cool thing is it shows you what the sources are. So if you want to click on one, you can. One of the things that we're having him add is it gives the name of the article up top, and you can pursue that further. So this just gives you a sense of the kinds of answers that it's generating. But again, it's good for people that are brand new to it that might have questions like, hey, is carbon removal necessary? Or is carbon removal, what is it? How does it differ from CCS? Or can we wait to start carbon removal until after we fully decarbonize? So there's a lot of content that's on the back end of this that is helpful for it. So I put I went ahead and put the actual web page there. And then what we launched with today was a good essay on LinkedIn that kind of talks a little bit about where is it going? What can you expect to do with it? How do we do our quality selection and stuff like that? So, but anyway, we're really excited about it. We've gotten a lot of traffic on it today since going local with it. And there is on the bottom of it as well, in addition to frequently asked questions, there's a little user guide that kind of gives you some tips on how to use it most effectively. But we also have this feedback form, and we are in a beta stage. We're looking to get up to 1,000 documents within the next 2 weeks. But we want to hear how people are, how their experience was and how they would like to use it. But we also have on the bottom here the ability for people to go ahead and, if they have a peer-reviewed article that fits our criteria that they think should be included, we can crowdsource that a little bit, and they can upload it, and our team will make sure that it aligns with our criteria. But if people have awesome articles that are related to CDR, please share them with us, and we'll review them. And if they pass muster, we'll go ahead and upload them. Just keep growing and growing and growing from there. And there's some additional features that are getting added as well, which are really excited, that will allow people to use tags. So if you say, I want to know about laws, or I want to know about laws related to direct air capture, they can put those in the search box itself, and it'll winnow it down even a little bit more. And all of the documents that we use will also have tags on it. So that'll just make, I think, the search even a little bit more pinpointed for people who have very particular things that they're looking for. So, Sebastian, I'm glad you enjoyed it. Thanks for the nice words. So anyway, wanted to just share that with everybody here. I think it's going to be pretty useful, and it's going to continue to evolve, and it's getting a lot of enthusiasm. So, all right, that's all I had. Anybody have any other ideas or thoughts before we sign off? All right. Well, happy prompting on that, and we'll reconvene next week. All right. Bye, guys.
Bye.